Yeah, hi. Uh, in this video, let us discuss about the tensile, compressive, as well as shear stresses. Tensile stresses were not shown in this slide, but tensile stresses are just opposite to this figure. The compressive stress is shown here. Tensile stress is just opposite to this one. Compressive and shear stresses are the two fundamental type of stresses that material experience under the load. While the load is getting applied, we can experience the compressive as well as the shear stresses. Compressive stress is the stress experienced by a material when it is subjected to forces that pushes it. Instead of pushing, if it is pulling, that kind of stresses are known as tensile stresses. The compressive stresses are the stresses experienced by the material when it is subjected to forces that push it together, compressing it. This stress tends to shorten the material in the direction of the applied force, whereas the tensile stress extends the material in the direction of the applied force. The characteristics of compressive stresses are shown here. The nature of the compressive stress is normal stress acting perpendicular to the surface. Effects. It can cause buckling in the slender structures or crushing in short, thick. Applications. Pillars, columns, and supports in buildings are often designed to resist the compressive stress. Example is a concrete column supporting a building experiences compressive stress due to the weight of the structure. Shear stress. Shear stress occurs when a material is subjected to forces that cause it to slide parallel to its cross-sectional area. This stress arises due to tangential forces. So because of the tangential forces, shear stresses are getting. Shear stresses are the important stresses which are occurring when a material is subjected to the forces that cause it to slide parallel to its cross-sectional area. The characteristics of shear stress. Nature of the shear stress is it is acting tangentially to the surface. The effects of shear stress. Shear stress can lead to shearing or sliding failure along a plane. Shear stress can lead to shearing or sliding failure along a plane. Applications of shear stresses. Bolts, rivets, and beams are often designed considering the shear stresses. Example, a pair of scissors cutting paper generates shear stress at the cutting edge. Let us discuss the comparison between the compressive as well as shear. Property, compressive stress and shear stress are tabulated. Direction, compressive stress acts perpendicular to the surface, whereas shear stress acts parallel to the surface. Cause, compressive stress is due to the compressive forces, whereas shear stress is due to the tangential forces. Effect, compressive stress shortens or crushes the material, whereas shear stress causes the material layers to slide past each other. Failure mode. Compressive stress makes crushing or buckling, whereas shear stress causes shearing or sliding along the plane. Practical example of a compressive stress is a dam which has water pressure applies compressive stress to the dam walls. Practical example of shear stress. It is in the beam subjected to bending. Shear stress develops within the cross section of the beam. Thank you. So here we discussed about the tensile, compressive as well as shear stress.